Okay. You can also do early functional test design because the functional test doesn't depend on the implementation. So program code is not actually necessary for this. And you can only have the description of the intended behavior, or even if you have an incomplete or informal specification, you can start drafting the test cases, and then yeah, you can later refine it to get a better, more precise version later. So to compare functional tests versus structural tests, which means the test that depends on the code, there are some benefits for the functional test. First, functional tests can apply at all the granularity levels. So you can apply it for unit tests by basing on the module interface spec or the function or method spec. And you can look at it from the header of the method. And you can do functional tests in integration tests by looking at the API or subsystem spec to see how the module call each other. And at the system level, we can look from the system requirement spec, and then you create the functional test based on the requirements. And regression test, which means you rerun the test on existing from on the new version of the system. This can also rely on the system spec, and you can use the history of bugs to improve the test suite as well. Okay. But compared to the structural test or the one that based on code, mostly they can apply on only unit test level and integration test level. So beyond that, you need to come back to other techniques like functional tests anyway. So how can we derive from specifications to the test cases? First, we would need to decompose the specification. We would need to understand the specifications in detail and try to break them down. Okay. Then we select the representatives or values to be used as test cases. And then we create test specifications, which means we create the test cases, the expected output, test values, expected output. And the last one, you produce and execute the actual tests and collect the results. So from the functional specifications, we decompose it into testable features or cases. So you perform some decomposition here, trying to understand what are the testable features that you can apply the test on. And then you select the representative values based on some model of the software that you have. You create the test case specs, and then you derive the actual test cases. Okay? And then you apply the test cases on the software. So we will apply some of the techniques such as equivalent class partitioning and boundary value analysis. So we divide the input space into multiple partitions. So this is like first partition, second partition, third partition, and fourth partition. We select the representative value for each partition. And then we also select some value at the boundaries of the classes. Boundary values as well. Okay, so apply the concept like equivalent class partitioning and boundary value analysis can help us to do this kind of functional test more effectively. So let's go through one example. This is an example of a leap year program. Okay, a leap year means a year that has 366 days, or the year that has 29 days for February. Okay, so the explanation of the computation is like this. We can consider this as a system spec. A leap year is every year that is exactly divisible by 4, except for the years that are exactly divisible by 100. Okay, so this is one exception. But these century years are still leap years if they are exactly divisible by 400. So try to understand the spec a bit. You can pause the video for a minute and then think about this and how you would decompose this specification, and resume the video when you are ready. Okay, so let's try to decompose this problem. So first, we have a leap year. The first case is if year is divisible by 4. Second, if the year is divisible by 400. And it will not be a leap year if it's not divisible by 4, or when it's divisible by 100. Okay, so that's what we have from the specification. So let's say we have 4 cases. Okay, let's think about the 4 possible cases that we have for testing the leap year and write it down. And then after you finish this, you resume the video and see what are the results. Okay, so let's see an example of a leap year problem. So a leap year is a year that has 366 days, or the year that has 29 days for February. So we are testing a program that gets an input as a year, and then it outputs whether this year is a leap year or not. The specification looks like this. A leap year is every year that exactly divisible by 4, except, sorry, change the color, except the one that are exactly divisible by 100. They will not be a leap year. But if they are divisible by 400, then they are still a leap year. Okay. So the first thing after we read this specification is that we try to decompose the spec into multiple cases. And this is similar to creating the classes for the input. Okay. So in this case, we have 4 cases. Okay. The first one is when it is not divisible by 4, then it is not a leap year. But if it is divisible by 4, then it is a leap year. The third case is it is divisible by 4 and also divisible by 100. This will not be a leap year. And the last one is if it is divisible by 4, divisible by, by 100 and also divisible by 400, then it is a leap year. Okay, so this is a leap year. Leap year equals true. This is not a leap year. So leap year equals false. This is also a leap year. So leap year equals true. And this is not a leap year. So leap year equals false. Okay. And these are some of the example of the test value that you can choose. So if you know that the year must be divisible, okay, so if it's divisible by 4 but not divisible by 100, you can select some year which is 2016, 2020, for example. If it is the one that are not divisible by 4, you can select 2015, 2017. If it is divisible by 4, divisible by 100, and also divisible by 400, you would get some century years like this: 2000, 3000, 4000, okay, or 2400, this kind of thing. And if it is divisible by 4, divisible by 100, but not divisible by 400, then you would get this kind of years, right? Okay. Yeah, I need to also add this, but it is not divisible by 400. Okay, so for this problem, we have the specification, and then we break it down into multiple cases. So there are 2 cases that are leap years, and there are 2 cases that are not leap year. And then with that, we derive the test case value, and then we derive the expected output. And that would be the technique that we can use for functional tests. And that's all for this module. See you in the next module.